Hello and welcome to Newton's Laws with Erica, Emily, Noel, and Fallon.
In this video, we will portray Newton's first, second, and third laws through various experiments.
We will show Newton's first law with a yo-yo demonstration, Newton's second law will be displayed through a swing demonstration, and Newton's third law will be displayed through a bouncy ball demonstration.
Always the very first one, objects keep doing what they're doing, till the net force has been applied. It's too late cause I did not know if I could my seatbelt on, force would have kept me in the car. And when I got home, before I went to bed, got my physics book to study again.
Newton's first law states that every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero net force.
This law is also called the law of inertia.
Have you ever noticed that it's harder to start pedaling your bike than it is to ride at a constant speed?
Or wondered what causes your bike to move?
Newton recognized that things tend to keep on doing what they're already doing. So an object in motion tends to stay,
And an object at rest tends to stay at rest.
We will demonstrate this law through a yo-yo demonstration.
Due to Newton's first law, this yo-yo will continue moving due to inertia.
The yo-yo will continue moving until an unbalanced force like gravity and friction slow it down and eventually stop it.
We will now show an example of this. Pull the yo-yo down so that it's at the end of the string.
The friction between the string and the yo-yo is an unbalanced force working against inertia and acceleration.
The yo-yo got inertia and acceleration from throwing it down.
This made enough acceleration and inertia to last until gravity and force eventually stopped it.
Always my favorite one, force can cause acceleration, and only mass can resist. That's why my car went slow. I haven't just wrote a list, could have been to the checkout line. And when I got home, before I went to bed, got my physics book to study again.
Newton's second law states that the acceleration produced by a non-zero net force on an object is directly proportional to the magnitude of the net force.
It's the same direction as the net force and is inversely proportional to the mass of the object.
This law will be demonstrated through a swing demonstration.
For this demonstration, we will put one person on one swing and two people on another swing. This is done so the masses are clearly different.
We will then push each swing with the same amount of force.
You will see that the lighter swing will travel much higher than the force with more mass.
So the more mass there is, the force required to push the object is greater.
This can be shown through the equation force equals mass times acceleration.
Always the strangest one. Every action has a reaction that's equal and opposite. And my best friend did not know the force was on the trampoline. Reaction set me in the air. And when I got home, before I went to bed, got my physics book to study again.
Newton's third law states that for every action there's an equal and opposite reaction.
Have you ever wondered why a ball bounces back at you after hitting the ground?
Newton's third law explains why this happens.
As the bouncy ball hits the floor, it causes a downward force on the floor.
This is the action.
The floor reacts by pushing on the ball with the same force but in the opposite direction.
This is the upward direction, causing it to bounce back up to you. Together, the ball and the floor form what is called the action-reaction pair. Thanks for watching Newton's 3 Laws.